Hi everybody, thanks for tuning in and watching this little video. I'm going to go over the answers to this little worksheet that we put together about describing graphs. We're trying to use all of our good mathematical descriptors like domain and range, increasing or decreasing functions, maximum or minimum points, intercepts, any lines of symmetry, whether the graph is continuous or discrete, and if there are any asymptotes. Not all of these graphs have all of those attributes, so when they don't, you just write none. For example, and we've talked about this first one already, so I won't spend too much time on it, but there's no real line of symmetry on this unless you are clever enough to come up with this equation, the line that goes at a diagonal that divides this segment into equal parts. But for sure, there are no asymptotes for this graph, and so some things you just write none. So let's move to the second one, since we've already talked about that first one a couple of times in class. So this is actually a square root curve, that's what it looks like, and the domain is from -4 to infinity, and the range is from 0 to infinity. So the -4 is over here on the x-coordinate, goes forever, that's what that is. And the range is this y value of 0, and it goes up forever. That's what the arrow means. It's an increasing graph because it's going up from left to right. There is no maximum point. It never stops going up, so there's no maximum. There is a minimum point, though. It's right there. Really, we can just use the y value of the minimum points or maximum points if we have any. The x-intercept is at -4. The y-intercept is at +4. There's no line of symmetry for this graph. It is continuous, and there is no asymptote. This is an exponential function. All right, it's got a horizontal asymptote at y equals, sorry, not y equals 0. That's a mistake. That's 1, 2. It's y equals 2, not 0. Sorry about that. Let me fix that for you right now. All right, y equals 2 is the horizontal asymptote. It is a continuous graph. There is no line of symmetry. There is no maximum point because it's always going up. And there's actually no minimum point. That's kind of a strange one because it's always going down. It never technically actually gets to y equals 2, but it's always getting closer, and therefore there really isn't any minimum point. If you were going to say there isn't a minimum point, you would say +2, but it's not, doesn't ever actually get to +2. So can't really say there's a minimum point either. There is no x-intercept for this graph. It never crosses the x-axis, but the y-intercept is at 2.5, and I marked that on the graph. The domain is all real numbers, so -infinity to +infinity, left to the forever, right forever. And the range is from, again, I made that mistake. I think I was looking at the wrong, oops, there we go. The range is actually from 2 to infinity. And it is an increasing graph. Okay, so this next one, we're going to go a little bit faster now. The domain is from -infinity to 2, and the range is from -infinity all the way up to 5. So that's the domain and range for that graph. This graph is increasing and decreasing, and as we get more sophisticated in describing graphs, we'll be a little bit more specific about this. But right now, you can just say it's both. It's increasing and decreasing. It's increasing as you go left to right up to that point, and it turns around and starts decreasing to there. It has a maximum y value of 5. It does not have a minimum value. It's got an x-intercept at around -2.2. We don't know exactly what it is, but it's about -2.2, and a y-intercept of +5. It does not have a line of symmetry, and it is a continuous graph, and there is no asymptote. Let's do the one on the back. The one on the back is kind of funny. This is an interesting kind of graph. It has a domain from 0 to 10, so notice that the filled-in dot right there is at 0. These are open circles at the right end of each of those. So there's an open circle right here. That's why you would put a parentheses for the domain for that point right there. The y value or the x value is 10, but it doesn't actually get to 10. It comes right up very, very close to it, but it doesn't actually reach it. So the domain is from 0 to 10, but not really including the 10. The range is interesting also because the only y values in this function, that's what the range describes, are the y values, and the only y values are 0, 2, 4, 6, 8, 10. There's nothing in between them. So you wouldn't say from 0 to 10 because that would include all these values in between these little pieces. So the range is literally just that list of numbers and nothing else. It is increasing, it's going up from left to right. It has a maximum value of 10 and a minimum value of 0. It has an x-intercept at 0 and a y-intercept at 0. You could say also the x-intercept is from 0 to, what was that, 2, to 2, which is pretty strange because that's just a whole section of the graph. It's right on the x-axis. There's no line of symmetry, and this is our only actual discrete graph on this page. So this is discrete, and there is no there's no asymptote. This is a semicircle, and the domain is from -4 to +4, and the range is from 0 to +4. It's increasing and decreasing like that other one, so it has both. It has a maximum value of 4 and a minimum value of 0. It has two x-intercepts, -4 and +4, and a y-intercept at +4. There is a line of symmetry. It's the vertical line, x equals 0, x equals 0, and it is a continuous graph. There is no asymptote for this graph. Okay? So there's your answers for those. This last one I thought I would draw for you. It's got to be a decreasing graph with a range of from x to greater than or equal to 0, and a range between -3 and +2. So it also has a maximum value at 0, 2. So it's got that point right there. It's got a y-intercept of 2. It's got an x-intercept at 4. So here's the x-axis, so 4 would be right there. All right? And it does not have a line of symmetry. It's continuous, and there's an asymptote at y equals -3, which I've already drawn in for you. That's that dotted line at y equals -3. So one way to sketch this graph would be something kind of like this. Kind of going down here through that x-intercept at 4, and just kind of gradually flattening out to go right along that asymptote. Okay, something like that. It stops right here, so we don't put an arrow on this end, but we can put an arrow on the other end because it's supposed to go forever. So I'm going to make it a little bit darker. And there you go. That's a decent graph. You could have other graphs that look a little bit different than that, but that's one answer to that question. Okay, thanks for watching. There is an extra credit question, though, which you'll only realize if you watch this video. So here's the question. What is the name of this shape? It's supposed to be a drawing of a three-dimensional object. Okay, it's got a pentagon on the bottom and a pentagon on the top. And so what is the name of this shape? If you write that answer into the forum tonight, you'll get some extra credit. Okay, good. I'm glad you watched till the end. Bye.